The end of everything. How the universe might die. Picture this. You're lying on your back on a warm summer night, staring up at the countless stars scattered across the dark canvas above you. The Milky Way stretches from horizon to horizon, and in that moment, the universe feels infinite, eternal, unchanging. But here's a question that might send a chill down your spine. What if everything you're looking at, every star, every galaxy, every particle of matter and energy in existence, is slowly, inexorably marching toward its ultimate demise? This isn't the premise of a dystopian science fiction novel. This is one of the most profound questions that modern cosmology grapples with, and the answers are both more fascinating and more unsettling than you might imagine. Today, we're going to embark on a journey to the very end of time itself, exploring how the universe that gave birth to stars, planets, and life might one day meet its final fate. But before we dive into the cosmic abyss, let's start with a seemingly simple question. When you look up at the night sky, what do you actually see? You see light, photons that have traveled across vast distances to reach your eyes. Some of that light left its source just a few years ago from nearby stars, while other photons have been journeying through space for millions or even billions of years from distant galaxies. In a very real sense, when you look up at the night sky, you're looking back in time, witnessing the universe's history written in starlight. This realization leads us to perhaps an even more profound question. If we can see the universe's past by looking into space, can we also peer into its future? Can we use the laws of physics to predict not just tomorrow's weather or next year's eclipse, but the ultimate destiny of everything that exists? The answer, remarkably, is yes. And the story of how we arrived at this answer is one of the most extraordinary intellectual adventures in human history. Let's begin our journey in the early 20th century, when our understanding of the universe was about to undergo a revolution that would make Copernicus's heliocentric model look like a minor adjustment. In 1915, Albert Einstein published his theory of general relativity, fundamentally changing how we think about space, time, and gravity. But even Einstein, brilliant as he was, initially resisted some of the implications of his own equations. When Einstein first applied his field equations to the universe as a whole, he discovered something troubling. His equations predicted that the universe should either be expanding or contracting. It couldn't remain static and unchanging as everyone, including Einstein himself, believed it should be. This was so contrary to conventional wisdom that Einstein did something he would later call his greatest blunder. He added a term to his equations called the cosmological constant, essentially a repulsive force that could balance gravity and keep the universe static. But the universe had other plans. In the 1920s, an astronomer named Edwin Hubble was making observations that would shatter our cosmic complacency forever. Using the 100-inch telescope at Mount Wilson Observatory, Hubble studied the light from distant galaxies and made a discovery that would change everything. These galaxies were moving away from us, and not just moving away. The farther away they were, the faster they were receding. This was the observational evidence for what we now call the expanding universe. Imagine the universe as the surface of a balloon being inflated. As the balloon expands, every point on its surface moves away from every other point, and the farther apart two points are, the faster they separate. This is exactly what Hubble observed in the cosmos. But here's where the story takes a fascinating turn. If the universe is expanding now, what does that tell us about its past and future? If we could run the cosmic movie backward, we'd see all the galaxies getting closer and closer together until, at some point in the past, everything in the universe would have been compressed into an incredibly hot, dense state. This was the birth of the Big Bang Theory, though that name wouldn't be coined until later, and ironically by someone who opposed the idea. The expanding universe also raised an immediate question about the future. If gravity is always attractive, shouldn't it eventually slow down and halt this expansion? Shouldn't the universe eventually stop expanding and start contracting, ultimately collapsing back into the dense state from which it emerged? This scenario, known as the Big Crunch, was for decades considered the most likely fate of our universe. But the universe, as we've learned time and time again, is far more strange and wonderful than our intuitions suggest. To understand why, we need to dive deeper into the fundamental forces that govern cosmic evolution. Gravity, the force that keeps your feet on the ground and the Earth in orbit around the Sun, operates on a simple principle. Every piece of matter attracts every other piece of matter. In the context of the expanding universe, gravity acts like a cosmic brake, constantly trying to slow down the expansion. For most of the 20th century, cosmologists assumed this was the whole story. They thought the key question was simply whether there was enough matter in the universe for gravity to eventually win out over the expansion. If there was enough matter, what they called a closed universe, then gravity would eventually halt the expansion and reverse it, leading to a big crunch. If there wasn't enough matter, an open universe, then the expansion would continue forever, but gradually slow down. There was also a third possibility, a flat universe balanced precisely on the knife's edge between expansion and collapse, where the expansion would slow down but never quite stop. This seemed like an incredible coincidence, requiring the density of the universe to be tuned to an almost impossible precision. Scientists spent decades trying to measure the universe's density, counting galaxies, measuring their masses, and calculating whether we lived in an open, closed, or flat universe. But in the 1990s, two teams of scientists set out to make the most precise measurements yet of the universe's expansion history. What they found defied all expectations and won them the 2011 Nobel Prize in Physics. The teams, led by Saul Perlmutter, Brian Schmidt, and Adam Rees, used a special type of stellar explosion called Type 1a supernovae as standard candles to measure cosmic distances. These supernovae are remarkably consistent in their brightness, making them ideal cosmic lighthouses for mapping the expansion of the universe across billions of years of cosmic history. When they analyzed their data, expecting to find evidence that the universe's expansion was slowing down due to gravity, they instead discovered something that seemed impossible. The expansion of the universe is accelerating. Not only is the universe getting bigger, but it's getting bigger faster and faster as time goes on. This discovery was so unexpected that both teams initially thought they had made an error. They double-checked their calculations, refined their measurements, and looked for systematic errors that might explain away this bizarre result. But the data was clear. The universe's expansion is indeed accelerating. To explain this acceleration, scientists had to propose the existence of something completely new and mysterious: dark energy. This isn't energy in the way we usually think of it. It's not the kinetic energy of motion or the potential energy stored in a stretched rubber band. Dark energy appears to be a property of space itself, a kind of repulsive force that pushes the universe apart faster and faster. Here's the truly mind-bending part. Dark energy makes up approximately 68% of the universe. Another 27% consists of dark matter, mysterious particles that we can detect through their gravitational effects, but that don't interact with light. The ordinary matter that makes up stars, planets, and people, everything we can see and touch, accounts for just 5% of the universe. We are living in a cosmos dominated by two forms of dark stuff that we barely understand, and one of them is actively pushing the universe toward an ever faster expansion. This realization has profound implications for the ultimate fate of everything. But before we explore those implications, let's take a step back and consider the deeper philosophical questions this raises. What does it mean to live in a universe where 95% of everything is invisible and mysterious? What does it tell us about the limits of human knowledge and the nature of reality itself? Throughout history, humans have repeatedly discovered that the universe is stranger than we imagined. We thought the Earth was the center of everything until Copernicus showed us we orbit the sun. We thought our solar system was the entire universe until we discovered other stars and galaxies. We thought our galaxy was the entire universe until we realized it was just one of billions. Each time, we've had to expand our conception of reality and acknowledge how much we don't know. The discovery of dark energy represents perhaps the most humbling revelation yet. It's as if we've been studying what we thought was the complete script of a play, only to discover that we've been looking at footnotes, and the actual story is written in invisible ink that we're only just beginning to detect. This brings us to one of the most fascinating aspects of modern cosmology, the interplay between observation and theory, between what we can measure and what we can imagine. The story of how scientists piece together the fate of the universe is a testament to human ingenuity and creativity in the face of cosmic mysteries. Let's return to the question of the universe's ultimate destiny. With dark energy driving an accelerating expansion, the old scenario of a big crunch becomes extremely unlikely. Instead, we're faced with several possible endings, each more strange and wonderful than the last. The first and currently most probable scenario is known as the heat death, or big freeze. In this scenario, the universe continues expanding and cooling forever. Stars will eventually exhaust their nuclear fuel and die out. Black holes will slowly evaporate through a quantum mechanical process discovered by Stephen Hawking. Eventually, after an almost incomprehensibly long time, far longer than the current age of the universe, even the largest black holes will disappear, leaving behind a cold, empty cosmos filled with nothing but the occasional elementary particle. But the timeline for this cosmic ending is so vast that it challenges our ability to comprehend it. The universe is currently about 13.8 billion years old. In comparison, the last stars won't die out for approximately 100 trillion years. That's more than 7,000 times longer than the universe has already existed. And the evaporation of the last black holes will take even longer, perhaps 10 to the power of 100 years or more. To put this in perspective, imagine the entire history of the universe from the Big Bang to today compressed into a single year. On this cosmic calendar, human civilization would occupy less than the last second of December 31st. The death of the last stars wouldn't occur until about 7,000 years later on this imaginary calendar, and the evaporation of black holes wouldn't be complete for trillions upon trillions of years after that. These numbers are so large they become almost meaningless to our human brains, which evolved to deal with timescales of minutes, hours, and years. But they highlight something profound about our cosmic situation. We exist in the very early stages of what may be an incredibly long-lived universe. We're living in the cosmic equivalent of the first few moments after sunrise, when the possibilities seem endless and the day stretches out before us. But there are other possible endings to consider. What if our understanding of dark energy is incomplete? What if this mysterious force that's currently accelerating the expansion isn't constant over time? One possibility is that dark energy might actually be getting stronger. If this happens, the acceleration of the universe's expansion would increase until it becomes so extreme that it tears apart everything: galaxies, stars, planets, atoms, and even the fabric of space and time itself. This scenario is known as the Big Rip, and it could occur in as little as 22 billion years, practically tomorrow on cosmic timescales. In a Big Rip scenario, the story would unfold like a cosmic horror movie played in reverse. About 1 billion years before the end, the expansion of space would become so rapid that galaxies would lose the ability to hold themselves together gravitationally. They would dissolve into collections of isolated stars floating in an increasingly empty void. About 60 million years before the Big Rip, the expansion would become so extreme that even our own galaxy would be torn apart. The sun and other nearby stars would go their separate ways, leaving the solar system adrift in an ever-expanding wilderness of space. Roughly 3 months before the end, the expansion would overcome the gravitational binding of our solar system itself. The planets would spiral away from the sun, which would continue burning, but would no longer have any companions on its lonely journey through the cosmos. In the final moments before the Big Rip, even atoms would be torn apart as the expansion of space overwhelms the electromagnetic forces that hold electrons in orbit around atomic nuclei. In the very last instant, even the fundamental particles themselves might be shredded as space-time itself is pulled apart at the seams. It's a scenario that makes even the heat death seem cozy by comparison. But there's something almost poetic about it too. The idea that the universe might end not with a whimper, but with the ultimate expression of the same force that created it in the first place, the expansion of space itself. There's yet another possibility that's even more mind-bending. What if the universe is cyclical? What if the Big Bang wasn't the beginning of everything, but just the latest in an infinite series of cosmic births and deaths? This idea, sometimes called the Big Bounce or cyclic universe model, suggests that the universe might expand, reach a maximum size, then contract back down to a hot, dense state similar to the Big Bang, only to bounce back and begin expanding again. In this scenario, our universe would be just one cycle in an eternal cosmic rhythm, like a universal heartbeat that's been pulsing for infinite time and will continue pulsing forever. The cyclic model faces significant theoretical challenges, particularly the question of what could cause the universe to bounce rather than collapse into a singularity. Some theories propose that quantum effects might prevent such a collapse, while others suggest that our understanding of physics in extreme conditions is simply incomplete. But the philosophical implications of a cyclic universe are fascinating. If true, it would mean that everything, every star that has ever shone, every planet that has ever formed, every life form that has ever existed, might recur again and again in endless repetition. Perhaps there have been countless versions of Earth, countless versions of human civilization, countless versions of you and me having this very conversation across infinite cosmic cycles. This brings us to one of the deepest questions in cosmology. What does it mean for something to end if it might also be reborn? And what does it mean to exist in a universe where our ultimate fate is fundamentally uncertain? These questions highlight the profound connection between cosmology and philosophy, between our understanding of the physical universe and our understanding of meaning, purpose, and existence itself. The ancient Greeks wondered about the nature of the cosmos and our place in it, and we're still grappling with fundamentally similar questions today, albeit with much more sophisticated tools and observations. But let's zoom in from these vast cosmic scales to consider what the universe's ultimate fate might mean for life itself. After all, we're not just passive observers of cosmic evolution, we're part of it. Life, intelligence, and consciousness have emerged from the same physical processes that govern the expansion and evolution of the universe. This raises fascinating questions about the future of life and intelligence in the cosmos. If the universe is heading toward a heat-death scenario, with temperatures gradually approaching absolute zero and all sources of energy slowly being exhausted, can life find ways to survive and even thrive in such conditions? Some scientists have seriously considered this question. Freeman Dyson, the brilliant theoretical physicist, once calculated whether life could theoretically survive forever in a universe heading toward heat death. His conclusion was optimistic. If life could become more and more efficient at using energy, and if intelligent beings could learn to think more slowly as the universe cooled down, then consciousness might be able to persist indefinitely, even in a cooling cosmos. Imagine a future where intelligence has learned to hibernate for longer and longer periods, waking up occasionally to think a few thoughts, then going back to sleep to conserve energy. As the universe grows colder and energy becomes scarcer, these periods of activity would become briefer and the periods of hibernation longer. But subjectively, to the conscious beings experiencing this existence, time would feel normal. They would experience the same richness of thought and feeling, just stretched out over ever longer cosmic timescales. It's a strange but oddly hopeful vision. Consciousness as a kind of cosmic survivor, learning to adapt to any conditions the universe might throw at it. But it depends on assumptions about the nature of life and consciousness that we're still far from understanding. Other scientists have considered even more exotic possibilities. What if advanced civilizations could learn to manipulate space and time itself? What if they could create new universes, pocket dimensions, or find ways to escape the ultimate fate of our cosmos entirely? These ideas venture into the realm of speculation, but they're grounded in real physics. We know that black holes can be thought of as gateways to other regions of space-time. We know that quantum mechanics allows for the possibility of tunneling between different energy states, and we're beginning to understand that information, not just matter and energy, might be a fundamental aspect of reality. Could sufficiently advanced intelligence find ways to encode itself in the very structure of space-time, persisting even after all matter has decayed and all energy has been exhausted? Could consciousness find ways to hop from one universe to another, surfing the quantum foam of reality itself? These questions sound like science fiction, but they emerge naturally from our current understanding of physics, and they highlight something remarkable about our cosmic situation. We live in a universe where intelligence has emerged and is now capable of contemplating its own ultimate fate. Think about this for a moment. For billions of years after the Big Bang, the universe evolved according to blind physical processes: gravity gathering matter into the first stars, nuclear fusion creating heavier elements, those elements forming planets, and eventually, the complex chemistry that gave rise to life. But now, roughly 13.8 billion years after it all began, the universe has become self-aware through creatures like us. We are literally the universe thinking about itself, asking questions about its own nature and destiny. This suggests that consciousness might not be just an accidental byproduct of cosmic evolution, but perhaps one of its most significant achievements. But this realization also brings with it a sense of cosmic responsibility. If we are indeed the universe's way of understanding itself, then the knowledge we gain and the questions we ask become part of the universe's own self-discovery. Our quest to understand dark energy, to map the cosmic web of galaxies, to peer deeper into space and time, all of this is the universe's ongoing project of self-examination. This perspective transforms the question of the universe's ultimate fate from an abstract scientific puzzle into something deeply personal. We're not just studying the end of everything from the outside, we're part of the everything that might one day end. And this brings us to one of the most profound paradoxes in cosmology: the relationship between cosmic time and human time, between the vast scales on which the universe operates and the brief flicker of individual human existence. From a cosmic perspective, human life is incredibly brief. If the current age of the universe were compressed into a single day, all of human history would occupy just the last few seconds. Our individual lives would be measured in milliseconds. Yet from our personal perspective, our lives feel substantial, meaningful, filled with experiences and relationships that matter deeply to us. How do we reconcile these two perspectives? How do we find meaning in our brief existence when set against the backdrop of cosmic time? One answer might be that meaning doesn't require permanence. A beautiful piece of music doesn't become less beautiful because it eventually ends. A meaningful relationship doesn't lose its significance because it's temporary. The joy you feel watching a sunset doesn't become hollow just because the sun will eventually exhaust its fuel and die. In fact, perhaps it's precisely the temporary nature of things that gives them their poignancy and power. If everything lasted forever, would anything feel special or meaningful? If every moment stretched on for eternity, would any moment feel precious? This suggests a different way of thinking about the universe's ultimate fate. Instead of seeing it as a cosmic tragedy, the end of all stories, the final closing of the book, we might see it as part of what gives cosmic history its narrative structure and emotional weight. Every star that dies contributes to the creation of heavier elements that might one day form planets and living beings. Every black hole that evaporates returns its information to the broader universe in ways we're still trying to understand. Even the heat death of the universe could be seen not as an ending, but as a transformation, the conversion of all the universe's ordered energy into maximum entropy, a kind of cosmic equilibrium that might itself be beautiful in ways we can't yet imagine. But let's not get too comfortable with these philosophical consolations. The universe has a habit of surprising us, and some of those surprises challenge our deepest assumptions about existence itself. Consider, for example, the possibility that our universe might not be unique. Modern theories in physics, particularly those involving inflation and string theory, suggest that our universe might be just one bubble in an infinite multiverse, a vast collection of universes with different physical laws, different histories, and different fates. If the multiverse is real, then the end of our universe wouldn't be the end of everything, just the end of our local chapter in an infinitely larger story. Somewhere else in the multiverse, there might be universes that never experience heat death, universes where dark energy works differently, universes where life has found ways to thrive that we can't even imagine. This possibility simultaneously makes our universe seem less special and more precious. Less special because we're no longer unique. We're just one of countless possible worlds. More precious because our particular combination of physical laws, cosmic history, and evolutionary accidents is probably incredibly rare and unlikely to be repeated exactly. But the multiverse theory also raises unsettling questions about the nature of existence itself. If every possible universe exists somewhere in the multiverse, then somewhere there's a universe almost exactly like ours, but with tiny differences. A universe where you decided to have coffee instead of tea this morning. A universe where dinosaurs never went extinct. A universe where the fundamental constants of physics are slightly different and stars never formed. This leads to what philosophers call the fine-tuning problem. The physical constants that govern our universe, the strength of gravity, the mass of the electron, the rate of cosmic expansion, all seem to be precisely calibrated to allow for the formation of stars, planets, and life. Change any of these constants by even a tiny amount, and the universe might be a cold, empty place where nothing interesting ever happens. Is this fine-tuning evidence of design, suggesting that our universe was specifically created to support life? Is it evidence of selection bias, meaning we can only observe a universe that's capable of producing observers like us? Or is it evidence of a multiverse where all possible values of these constants exist somewhere, and we simply happen to find ourselves in one of the rare universes where everything worked out just right? These questions bring us to the very edge of scientific knowledge and into the realm of philosophy and metaphysics. But they're not merely academic puzzles. They shape how we think about our cosmic significance and our relationship to the broader universe. And they highlight one of the most remarkable aspects of our current situation. We live at a unique moment in cosmic history when it's possible to ask and potentially answer these fundamental questions. For most of the universe's history, no intelligent observers existed to ponder its fate. And if the universe is indeed heading toward heat death, there may come a time in the far future when such pondering is no longer possible. We exist in a brief window of cosmic awakening, a moment when the universe has become complex enough to support consciousness, but hasn't yet evolved so far that such consciousness is no longer possible. We are living in the universe's adolescence, a time of rapid change, discovery, and endless possibility. This realization brings with it both excitement and responsibility. The questions we ask and the discoveries we make during this cosmic epoch may be among the most significant events in the universe's entire history. We have the opportunity to be present at the moment when the universe first begins to truly understand itself. But our current knowledge also reveals the profound limits of human understanding. We know that 95% of the universe consists of dark matter and dark energy that we can barely detect and don't understand at all. We know that our theories break down at the very beginning of time and in the extreme conditions inside black holes. We know that quantum mechanics and general relativity, our two most successful physical theories, are fundamentally incompatible in certain situations. These limitations might be temporary. Perhaps future generations will develop new theories and technologies that allow them to peer deeper into the nature of reality. But they might also represent fundamental bounds on what any physical beings living within the universe can ever know about the universe as a whole. This uncertainty extends to our predictions about the universe's ultimate fate. While the heat-death scenario currently seems most likely based on our observations of dark energy, we're making these predictions based on an understanding of physics that we know is incomplete. The history of science is littered with confident predictions that turned out to be wrong because they were based on limited or incorrect understanding. Perhaps dark energy isn't what we think it is. Perhaps there are aspects of gravity that we don't understand on cosmic scales. Perhaps the universe operates according to principles that we haven't even begun to discover. Perhaps the very concept of an end to the universe reflects limitations in our thinking rather than inevitable features of reality. This uncertainty might seem frustrating, but it's also one of the most exciting aspects of our current situation. We're living at a time when humanity is making its first serious attempts to understand the universe's ultimate destiny. We're pioneers exploring the furthest frontiers of knowledge, and like all pioneers, we're operating with incomplete maps and imperfect tools. The journey of discovery is just as important as the destination, if not more so. Each new observation, each theoretical breakthrough, each moment of understanding represents a victory of consciousness over ignorance, of curiosity over complacency. Whether the universe ends in fire or ice, whether it cycles eternally or expands forever, the very fact that beings like us can ask these questions and work toward answers is itself a kind of triumph. And this brings us to perhaps the most important question of all. What should we do with the knowledge that the universe might have an ultimate fate? How should the possibility of cosmic endings affect how we live our lives, treat each other, and think about meaning and purpose? One response might be nihilism. If everything ends eventually, then nothing matters. But this seems to miss the point entirely. The temporary nature of individual human lives doesn't make them meaningless. So why should the temporary nature of the universe as a whole make everything meaningless? Another response might be urgency. If cosmic time is limited, then every moment becomes infinitely precious. This perspective emphasizes the importance of making the most of our brief time in existence, of cherishing our relationships, pursuing our passions, and contributing to the great human project of understanding and exploration. A third response might be humility, the recognition that we exist as tiny, temporary parts of a vast cosmic story that we're only beginning to understand. This perspective emphasizes our connection to the larger universe and our responsibility as conscious beings who can contemplate and appreciate the extraordinary phenomenon of existence itself. Perhaps the most appropriate response combines elements of all three: a recognition that our time is limited but precious, that our understanding is partial but growing, and that our existence is improbable but real. We are the universe's way of experiencing wonder, and that might be purpose enough. Consider this. Every atom in your body was forged in the nuclear furnace of a star or in the explosive death of a massive star as a supernova. You are literally made of stardust, and when your atoms eventually return to the cosmos, they may become part of new stars, new planets, new forms of life and consciousness. In a very real sense, you are a temporary arrangement of the universe that has somehow become aware of itself. This cosmic perspective doesn't diminish the importance of human-scale concerns: love, friendship, creativity, justice, beauty. If anything, it amplifies them. These experiences represent some of the most complex and remarkable phenomena that the universe has produced. When you feel wonder at a beautiful sunset, or love for another person, or excitement at learning something new, you are participating in some of the most sophisticated information processing events that have ever occurred anywhere in the cosmos. The universe has spent billions of years evolving the capacity for such experiences, and they may be among its greatest achievements. From this perspective, consciousness and culture aren't just byproducts of cosmic evolution. They might be among its most important goals, if we can speak of an unconscious process like evolution as having goals. This suggests that our responsibility extends beyond just understanding the universe's fate to ensuring that consciousness and culture can survive and flourish for as long as possible. If we are indeed living in a special epoch when the universe has become self-aware, then perhaps our most important task is to make sure that this self-awareness persists and grows. This might mean spreading life and consciousness beyond Earth, establishing human communities throughout the solar system and eventually among the stars. It might mean developing artificial intelligence that can extend and amplify human consciousness. It might mean preserving and expanding the accumulated knowledge and culture of our species so that future generations can build upon our discoveries. But it also means addressing the more immediate challenges that threaten our continued existence: climate change, nuclear weapons, social inequality, and the various ways we might destroy ourselves before we have a chance to fulfill our cosmic potential. From this perspective, the study of the universe's ultimate fate isn't just an abstract scientific pursuit. It's part of a larger project of ensuring that consciousness can survive and thrive for as long as the cosmos allows. By understanding the challenges that the universe will face over cosmic time, we can begin to think about how life and intelligence might adapt to meet those challenges. And this brings us back to the beginning of our journey. When you look up at the night sky, you're not just seeing the past, you're seeing the raw material from which the future will be built. Every star you see will eventually die, but its death will contribute to the birth of new stars, new worlds, new possibilities for life and consciousness. The universe's story is still being written, and we are both its authors and its characters. The ending isn't predetermined. It depends partly on the choices we make and the discoveries we achieve. Even if the ultimate cosmic fate is beyond our control, our response to that fate is entirely up to us. Perhaps this is the most remarkable thing of all. In a universe that began with the simple expansion of space and time, matter and energy, complexity has emerged. Galaxies formed, stars ignited, heavy elements were forged, planets coalesced, life began, evolution proceeded, and consciousness arose. And now consciousness is contemplating the very universe that created it, trying to understand its past, present, and future. We are the universe thinking about itself, and that thinking is itself part of the universe's ongoing evolution. Our questions and discoveries, our hopes and fears about cosmic endings, all of this is part of the universe's own story of self-discovery. Whether the universe ends in heat death or big rip, whether it cycles eternally or transforms into something we can't yet imagine, the fact that it produced beings capable of asking these questions and working toward answers is already a kind of victory over meaninglessness and chaos. In the vast cosmic scales of space and time, we are incredibly small and brief, but we are also incredibly complex and aware. We can feel wonder, create beauty, pursue truth, and care for each other. These capacities represent billions of years of cosmic evolution focused into conscious experience. The universe may be heading toward an ending, but it has also produced creatures capable of contemplating that ending and finding meaning in the contemplation itself. That capacity for meaning-making might be one of the most remarkable phenomena the cosmos has ever produced. So when you look up at the night sky again, remember that you're seeing not just the past, but also the ongoing story of cosmic evolution. You are part of that story, and your thoughts about it are themselves part of the universe's continuing development. The end of everything, if it comes, is still unimaginably far in the future. In the meantime, we have the extraordinary privilege of existing in a universe capable of producing consciousness, beauty, love, and understanding. These may be temporary phenomena on cosmic scales, but they are real and precious and worth preserving for as long as possible. The universe has given us the gift of awareness, and our response to that gift, how we use our consciousness, what we choose to value and protect and create, that response is our contribution to the cosmos that made us. In asking questions about the end of everything, we are participating in one of the universe's greatest achievements, the emergence of beings capable of wonder, curiosity, and hope. And that, perhaps, is meaning enough to sustain us through whatever cosmic futures await. The universe may end, but it has also begun and produced stars and planets and life and consciousness. We are here now, aware and questioning and marveling at it all. In the vast darkness of space and time that represents an almost unimaginable victory of complexity over simplicity, of awareness over unconsciousness, of meaning over meaninglessness. The story of the universe's ultimate fate is still being written, and we are both its witnesses and its authors. Whatever ending awaits, we have the privilege of participating in one of the most remarkable stories ever told. The story of how the universe learned to think about itself and what it discovered when it did. In the end, perhaps that's the most profound answer to the question of cosmic meaning. We exist not despite the universe's ultimate fate, but as part of the very process by which that fate will be determined. We are the universe's own attempt to understand itself, and every question we ask, every discovery we make, every moment of wonder we experience is part of that grand project of cosmic self-awareness. The universe may be stranger than we imagine. It may even be stranger than we can imagine. But it has produced us, and through us, it has become capable of imagination itself. That alone makes the cosmic journey worthwhile, whatever endings may come.